going to do this particular parts per million question. So remember again that this particular formula is a lot like the percent by volume one, except for now we're dealing with a million rather than 100, right? So what we're going to do is we're going to do this particular question where now we're solving for something that's not parts per million, okay? So when smoking, the parts per million concentration of carbon monoxide is approximately 200 parts per million. Determine the mass of carbon monoxide that would be present in an air sample having a mass of 9.6 grams, which is approximately 1 breath. So here we go. We've got 200 parts per million. We know that is parts per million, okay? Here we go. We also have this 9.6 grams. So grams meaning that this is a mass, and now I need to think to myself, is this the mass of the solution or the mass of the solvent? So I'm going to think to myself, okay, well, the question is asking me about carbon monoxide in an air sample. Okay, well, in this case, the air sample would be the solution, which means that that's what this 9.6 grams is. Okay, so the question is asking me again, how much carbon monoxide? So really it's asking me what mass of solute is there. Okay, so that's what the question is asking me for. So now I'm going to go ahead and I'm going to do my formula. So parts per million is equal to the mass of solute over the mass of solution times 10 to the 6th. Okay, so now again, like we did before, really the easiest way in order to set this question up is going to be to make a ratio. So I'm going to, divide by a million, so parts per million. Oh, sorry, this should have ppm. Okay, all over 10 to the 6 parts per million is equal to the mass of solute over the mass of solution. Now I'm going to do my substitution. So in this case here, we're talking about, 200 parts per million. So 200, okay, parts per million over 10 to the 6 parts per million. Okay, those would cancel off, is equal to, well, the mass of the solute, that's what I'm trying to find out, all over the mass of the solution, and in that case, it is 9.6 grams. I'm going to cross multiply and divide. Remember, when I cross multiply and divide, I'm starting at the thing directly across the equal sign from my unknown. So I'm going to start here at 200, and I'm going to multiply by 9.6, and then divide by a million. Okay, so how that would be written out here is 200 parts per million times 9.6 grams. Oh, sorry, that's pretty high for grams. There we go. All right, all divided by 10 to the 6 parts per million. Units, parts per million cancel out. My units is going to be in grams, which makes sense because what I'm looking for is a mass. So I'm going to put this in my calculator here at 200 times 9.6. Okay, all divided by 10 to the power of 6. Here we go, enter. And I get a value of, here we go, sorry, where's my, so 200 times 9.6 divided by a million, beautiful, 0.00192 grams. Okay, so what I'm now going to look at is I'm going to look back up here, okay, and I'm going to look for significant figures. Well, here I've got 3. Here I've got 2, so I need to report 2 significant figures. So what I need to do now is I need to do some scientific notation. So I need to move the decimal such that this number is between 1 and 10. So I'm going to move the decimal right here. Okay, I'm going to see, do I need to 2 significant figures? So these would be my 2. Does this need to round up? No, because it's less than 5. So this is going to be 1.9 times 10 to the, and I've moved this 3, so now negative 3 grams. And that's my answer. Perfect. Thanks for paying attention and following along with this answer for this particular question.